My name's Hugh and I'm a professional officer of Yeast 2.0 at Department of Primary Industry. Yeast 2.0 is the world's first designed organism. We've used DNA sequences to come up with an entire DNA sequence for a whole organism, and 10 laboratories around the world are all getting together to put them together inside a living cell and have the world's first designed organism. I'm working on a few different projects that span different industries, from fisheries and forestries to agriculture. But there's some very interesting ones about making things that plants normally make in new ways, and that gives our industries in New South Wales agility and security that they don't have at the moment. Well, DNA is relevant to any living organism, from plants and trees to people to small microbes like E. coli and yeast. So a lot of the skills that you pick up working on different organisms is completely transferable. So a lot of the work, for instance, that we did in the immune system of mice and humans still has relevance to a lot of the things that I did in algae to make biofuels, and is relevant to what I'm doing trying to put together large pieces of DNA inside a cell. It's a very fulfilling role, and sometimes it's very frustrating, but when it does work and you get an excellent result and you know that you're the first person to achieve something that's going to have a global impact, it's very, very rewarding. The biggest problem in the job, which I think we just have to accept but I wish wasn't the case, is repeating things over and over again. I wish that it worked perfectly the first time every time. It's a very, very challenging position, and you need to be able to deal with a lot of unexpected problems, and you need a lot of patience. You also need to be able to work in a team in difficult situations, which last quite a long time and a lot of time without breakthrough results, but it's very rewarding. You definitely need a bachelor's and a PhD degree to do the kinds of work that we do in the laboratory. A lot of the things are very routine and simple, but when it doesn't work, that's when you need to really be able to figure out what's going on. I did a bachelor's degree in biochemistry and biology, and then I moved on to a master's degree at Macquarie Uni on fungal cell factories, which is a kind of fungal biotechnology. And then after a while I came back and did a PhD on algal biofuels at Sydney, and also with the French Nuclear Energy Agency, who are interested in renewable energy. I went to high school in Newcastle, and then I went to uni in Sydney. I then did a master's in Sydney. I went overseas to London and worked for a few years at a research hospital. And then I came back and did part of my PhD in Sydney and part of it in the south of France. I think that Australia is going to be a global leader in agriculture moving forwards, and I think that the agriculture industry is a growing industry in Australia, especially moving forwards with the world's problems with food security. So I think there's a lot of opportunity for young people in agriculture. I would say persistence is what really pays off. If you are absolutely passionate and dedicated, those are two of the main qualities you'll need to succeed. And you need to find a way of following your dreams and be very open to chasing opportunities and making opportunities, and you'll get there. It's one of the robots that we're using in the Genome Foundry, which will automate the processes that we do and give us a lot more productivity, and allow us to spend more time doing intelligent designs. So if you look in here, This robot will look at a petri dish like this, and it will find where the colonies are. And this nozzle will find a yeast cell and transfer it from one of these plates to one of these liquid plates. And then we can take this liquid plate and transfer it into this robot. And from this robot, this cake here will dispense liquid into other plates, and we can do DNA extractions, and we can do multiple growth tests. And then from this robot, we can transfer to that robot, and we can use this to set up DNA experiments and do tests. And we perform those tests on this robot over here. So together, these form the start of the genome factory. So if you think, this protocol here, I can kind of do. So this is an example of a manual one. But if I was to then individually pick each of these colonies and then grow them up and individually do 96 extractions, that's already a week's worth of work with the analytics and downstream applications. If I use a robot to automate those 96 transformations and extractions and things like this, using this kind of platform, I could get all of the extractions done in a day and possibly some of the analytics as well. And so you really increase your turnover time. And you can also automate that so that you do not just one set, but this one's got enough space for sort of 10 sets of experiments. And so you can really increase the amount of productivity you get out of a workday by magnitude. And a lot of that data will feed into AI systems and then figure out what DNA does what to a cell and refeed that back into a next level of experiments.